This is a synchronous motor-driven electric clock. It's a telechron clock, made in 1929. Before clocks like this could be introduced into American homes, something else had to be introduced into the power plants of America to make the power line suitable for timekeeping. That something is this: the Warren Telechron Master Clock. Specifically, this is the movement out of such a master clock. It's owned by the city of Stillwater, and it's here because I'm going to be bringing it back to life. It's a very interesting marriage of this and this. Let's take a closer look at it. Here we see the synchronous motor assembly, identical to the one in that clock there. The output of this motor assembly is 1 RPM, and through a series of gears drives this hand round once every 5 minutes and winds this spring up by turning this gear here. To get the tension on the spring correct when initially running it, so you don't have to wait for the clock to run to wind up, there is a convenient handle here at the back for winding the spring. And as you heard there, the spring is broken and slips, so that will have to be remedied. There's a clutch right here to prevent overwinding of the spring by the motor. The spring drives through gearing this dial to display the current time, and the black hand on this dial, which also makes 1 revolution every 5 minutes. A third dial, which you can see where this mounts, also has a hand that makes 1 revolution every 5 minutes and is driven by another telechron motor through gearing. This serves as a backup for the hand on this dial. Obviously, this one has a timekeeping advantage that this one lacks. This one has no load other than the hand. Whereas this one, the motor driving this hand also has to wind up the spring to drive this, and top right the pendulum. We see an escape wheel and verge, just like in a conventional clock. And in fact, on the back, here's the crutch that comes down. The pendulum rod would go between the 2 fingers of that fork there, and this is the suspension post. So what we have here is an electrically rewound spring-driven clock for the regulator part, and that would be used to regulate the motion of this hand. The design of this is that the pendulum part of the clock is to be very, very accurate and is to be resynchronized with a time signal once every 24 hours. Time signals back then coming over the telegraph from railroad stations, which generally had a very high quality astronomical clock regulating their time system. And then this would be used by comparing this hand and this hand this would be used to make sure that the speed of the generators in the power station was running at the correct rate, which 60 cycles per second would mean that this hand and this hand would stay in perfect sync. As long as this hand stays in perfect sync with this hand, and this hand being regulated by astronomical clocks getting through time signals via the railways, the clocks of people in their homes would also read observatory time and be accurate. So this played a very large part in the regulation of the nation's power systems back before everything was connected together in a nationwide grid. Before these master clocks were made, no real effort was given by power companies to really regulate the frequency of the power lines closely. There was just no need for it. The electrical loads in use then would have been mostly light bulbs, and then the other primitive appliances coming in use, like the early toasters, the early electric irons, the early sewing machine motors, the early electric fan motors. And none of these applications required any synchronous use of the power. So there was, consequence, no real need to govern the frequency of the power lines that closely. Everything was close enough within the tolerances of the machinery. Henry Warren, the founder of Telecron, saw that in order to sell these, the frequency of the power systems had to be maintained close enough that the power line frequency could be used to run his synchronous motors for timekeeping. Thus, the reason why a master clock such as this had to be developed and sold to power companies. So work will be progressing on this, disassembling the movement, cleaning it just like an ordinary clock would be. A new coil will have to be wound for this. I could use one of the coils that's available, but I'm going to need long leads, and I'd like to have cloth covered wire on them. So I'll have a motor shop rewind both of these coils and put new cloth covered leads on them. Rebuilt rotors will have to be obtained, or these rotors will be sent off to be rebuilt so that the original rotors can be retained. And then a new suspension spring will have to be fitted, and then the clock regulated. It's interesting that most people that have these clocks now use them a bit differently. They use the, since the power lines of the nation's power grid now are regulated to 60 hertz by atomic clocks, you now use this hand here, it's not really a seconds hand, this hand here to regulate this hand and to speed up or slow down the pendulum clock. Well, I hope you've enjoyed watching this and learning about the first synchronous clocks and the first attempts to make the power line a system of timekeeping. Of course, that's what Telecron means, is time at a distance, and that's what they are doing when they use a clock like this with a synchronous motor. You are getting the time of a master clock in your home. And even today, these are the most accurate clocks that you can have in a home, is a synchronous motor-driven clock. So, this is Oklahoma Bridges. Thank you for watching.